Kia ora, Year 10. Over the next few days I'm going to try and video some of the JAF practice questions on linear equations and graphs. So in this video I'm going to cover the equation solving part up to relational level. We're going to start with some Uni Structural questions that are a lot like what we had in Year 9. And the basic idea here is looking for undoing operations, so using the inverse operation, and thinking about the order in which we have to work. So the first question is 3 times a number is equal to 1. The opposite of times is divides. So what do I have to do to undo this multiplication? Well, I have to divide both sides by 3. So we don't have to write this line out. Okay, but this is what we're actually doing. We're dividing each side by 3, and that's why on the left hand side we end up with x equals 1/3. Now for many of you, you'll be saying, well, it's really obvious that 3 times a number is 1 must give me an answer of 1/3, and that's fine when we're dealing with a one-step equation. So all you have to write here is that last line. You don't have to write this one. But when we get to more complicated problems, it's good to be able to think about how we undo steps. So the second question is 4x plus 7 is equal to 39, and this has got 2 steps in it. So we had a number, x, and we times it by 4, and then we added 7 to it to get 39. You can think of it as going like this. X times 4 gives us 4x, then it has 7 added to it. So when we undo, we go in reverse order. So on the next line we're going to have 4x is equal to 39 take away 7. Now when you first did these you probably wrote plus 7 take away 7. I'm happy that you don't do that step anymore if you're confident. So we could go straight to this. 4x is equal to 32. Next we have to divide both sides by 4, and again I don't need to see that division line, we can just see its result. So we get x is equal to 8. So lines of working that I'd really like to see in one like this are this one and this one. This one's optional, but if in doubt then write it down. Okay, the next one. So this is a 2-step equation, but it looks a bit more intimidating because it's in a different order. So we can work with it just as it is here, or we can reorder it. First I'm going to do it just as it is here. So we've got 5 here and we've got negative 13 here. We want to collect up those constants. So I'm going to subtract 5 from both sides. So we have 5 minus 6x minus 5 is equal to negative 13 minus 5. That leaves me with negative 6x is equal to negative 18, because 5 take away 5 is 0. Next we're going to divide both sides by negative 6. So we get x is equal to positive 3. A negative divided by a negative gives me a positive. So that's that one done. The other way that I could do it is that instead of having it written as 5 minus 6x equals negative 13, I could rewrite it like this. Negative 6x plus 5 is equal to negative 13. Sometimes students are more comfortable seeing it that way, but they're exactly the same thing. So if we're doing it that way, again we'll get negative 6x, subtract the 5 from both sides, gives us negative 18, and now again x is equal to positive 3. So that's the first 3 done. In D, we've got multiplication and division to undo. So question D is 3x over 4 is equal to 9. Thinking again about how that got set up, we had a number x, we times it by 3, and then we divided it by 4. And out popped 9. So when we undo, we're going to do it in backwards order. I'm going to come back to this because in this case, there are actually 2 ways that we could have set it up. So multiplying by 4 is going to give me 3x is equal to 9 times 4, which is 36. And now 3x equals 36. I undo it by dividing by 3, so we'll get x is equal to 12. Okay, that's, I think, the most obvious way to undo this equation, but it's actually not the only way here. Sometimes the order that things get set up in can be thought of in two ways, and this is one of them. We could think of here as having x divided by 4, giving me x over 4, and then being multiplied by 3. And that would give me 3x over 4. So I could undo this one, not by multiplying by 4 first. Right, so this is, I think, the way that most of you will choose to solve this problem. But we could also do it like this. I could divide both sides by 3, and then I'd have x over 4 is equal to 3. 9 divided by 3. And now we could multiply by 4, and that will give me x equals 12. Okay, on to the relational questions that are going to need a little bit more thought. So we've used up 6 minutes. I think I'm about on track. So let's have a look at what we've got and erase some of this. So there are some patterns in here that are worth noticing before we get underway. In this one, we've got brackets on the left-hand side. So one thing we can do with those is to expand them. Once we've done that, it turns back into an easy two-step pattern. In the second question, we've got x's on the left and the right-hand side. So the goal here is to get all of the x stuff to one side and all of the constant stuff to the other. Doesn't matter which side you do. This next one is an example of an inequality. We've looked at these a little bit in class, but not very much yet. The big thing to remember with inequations is that when I multiply or divide by a negative, I have to switch over my sign. Otherwise, they work exactly the same as simple equations. And this is just another one that's got a few steps in it to undo. So none of them should be too bad. So let's start with this. We've got 3 times x minus 2 is equal to 40. I'm going to show you two ways to do this one. The first way is to expand the brackets. 3x minus 6 is equal to 40. Add 6 to both sides. 3x equals 46. And now divide by 3. X is equal to 46 over 3. So it's a pretty ugly improper fraction, but it's correct because it's been simplified. Or it feels nicer to write it as a mixed number, 15 and 1/3. Okay, so that's one way to do that question, and I think that's probably the favourite way of most Year 10s. But here's another way. We don't have to expand the brackets first. We could just say this is 3 times all of this, and it equals 40. So I can undo the multiplication by 3. I'm going to divide both sides by 3. And that's what I get now. Here, I just have x take away 2. So I need to add 2 to both sides. X is equal to 40/3 plus 2. Getting a common denominator gives me, of course, the same answer. X is equal to 46 over 3, which is 15 and 1/3. Okay, on to the next one with x on both sides. So I think this is b from the relational. 5x plus 3 is equal to 2x minus 15. I'm going to choose to add this to both sides first. So we're going to get numbers going this way, and x is going this way. 5x plus 3 plus 15 is equal to 2x. 5x plus 18 equals 2x. Now it's time to subtract the 5x from both sides, leaving me with 18 is equal to 2x take away 5x. 18 is negative 3x, so x is equal to 18 divided by negative 3, which equals negative 6. Right, now let's have a look at C, which has got an inequation in it. So we've got 11 minus 5x is greater than 15. So before I start this, just a really quick review of what goes on with greater than or equal to signs. Just think about a number line and think about the numbers 10 and 15. So we can say that 10 is less than 15. Now I want you to think about multiplying both of those numbers by negative 1. So the two numbers we've now got would become negative 10 and negative 15. We can mark them on a number line. This is negative 10 and this is negative 15. Which one's bigger? Well, negative 10's bigger. It's higher up the scale. If you don't like thinking about that, think about temperatures and when is it colder? Is it colder when it's negative 15 or negative 10? There's definitely a lower temperature at negative 15. So negative 10 is bigger than negative 15. So when I multiply by negative 1, the sign has got to change over. Otherwise it's not a true statement anymore. So let's look at how that works with equations before I kick into this relational one. If I've got x is greater than 2, then that means that my answer is all of the numbers that are 2 or more. For example, 2.5 would be a part of the solution, 352, right? So that's all the numbers that are greater than 2. But negative x, when I times this by negative 1, negative x is less than negative 2. Okay, so if we look at all of these numbers, negative 2.5, negative 3, negative 352. All of them are less than negative 2. So we're going to see that coming up in lots of inequation problems. So let's look at how this one here works. What have we got? Let's see. 11 minus 5x is greater than 15. So we're just going to forget that this is an inequality and treat it as if it were an equal sign. I'm going to subtract 11 from both sides. That gives me negative 5x is greater than 4. Now I'm going to divide both sides by negative 5. So that gives me x, and here it gives me 4 divided by negative 5. When I multiply or divide by a negative, the sign must reverse. So my final answer is that, but that looks really bad because we have a really strong convention in maths that if we've got a positive divided by a negative, we write it like this. So we always change it to have the negative divided by the positive. Now these two things are exactly the same point on the number line, but this is like in maths that we don't write 1x, right? We just would write x. It's a really, really strong convention. So strong that if you wrote that, I think you'd probably get that marked wrong in a level 1 exam, but you'd definitely get that marked right. Now let's just look at how we can put this onto a number line. Remember that if we've got less than, strictly less than, that means that negative 4/5 is not in my solution, and we show it like this by doing an open circle. If it were less than or equal to, then we'd have the coloured in circle going backwards. Alright, one last question. I've got 1 minute to do it. Let's see how I go. Okay, 4x over 5 minus 3 is equal to negative 1. This is testing that you understand the order in which we have to undo operations. Here, the first thing I'm going to do is to add 3 to both sides. 4x over 5 is equal to negative 1 plus 3, which is equal to 2. So 4x over 5 is 2, and then multiplying by 5 gives me 4x equals 10. Finally, I get x is equal to 10 divided by 4. Right, not simplified yet, so we're not finished. That equals 5 over 2 as an improper fraction, or 2.5 as a mixed number. Alright, my time's up. I'll do some of the graphing ones later on this evening or maybe tomorrow night. Thank you for watching.